Alright, so this video is going to show the top 5 myths as a class. If you have any more questions before you take your quiz, make sure you contact me and let me know. Just to kind of talk about any issues you may be having. So for number 3, it says the table shows the prices a company charges to build the fences at various lengths. Write an exponential equation that best fits the data. So remember, when we do exponential, when we go to Desmos, exponential is y equals a times b raised to x. Okay, so when we do it in Desmos, it's going to be y1 a times b raised to x1, but you got to make sure you click log mode. If you don't click log mode, it's not going to give you the correct answer. Alright, so in Desmos, I'm going to come add the table, and I'm going to put that information in. Alright, and remember there's that little button down on the side, the little zoom fit button. So when I hit that, it's going to show my length for me. Now, it almost looks linear because you're not really seeing the entire pattern, but it does say exponential equation in the problem. So there's no reason to second guess anything because of the fact that it says exponential. So we know we're doing exponential. Alright, so we're going to come here and we're going to do y1, squiggle, ma times b. I'm going to raise that to x1. Make sure you click log mode. So down here at the bottom, I have a equals 58.82. Remember, I always try to use at least 2 decimal places. And b equals 1.26. So if I input those values and I make my equation, I have y equals 58.82 times 1.26 raised to x. So that go ahead and eliminates these 2 answer choices. So the question is then, estimate the cost if the length of the fence is 20 meters. Well, if I look at my problem, the length of the fence is the x value. So we're going to plug in 20 meters right here for x. So I'm going to come down here and I'm going to do 58.82 times 1.26. And I'm going to raise that to 20. And I get 5983.2, which would have been this answer. Alright. Alright, so the next one was number 5. It was talking about the residual. So it talks about the height of a tree, and it talks about the fact that they gave us a linear model, and it was recorded that it was 33 feet in 6 years. What is the residual? So remember, the residual is the actual minus the predicted. Okay? So your residual is your actual minus your predicted. So if I'm looking, I'm going to make a table. If the tree was recorded to have a height of 33, so a height of 33, and I put that in the wrong spot, after 6 years, so 6 and 33. So that was your actual. So what we're trying to find now is the predicted. So how do I find the predicted? Well, I find the predicted by plugging in my 6 into my equation. So we're going to say height equals 5.4 times 6 plus 1.3. Alright. And I have 5.4 times 6 plus 1.3. And I get 33.7. So if I take my actual, which is 33, and I subtract my predicted, 33.7, I get negative 0.7, which would have been B. All right, and a lot of people got this wrong just because you didn't read. So it talks about this is a scatter plot that shows the age versus the handspan. So if I'm looking at this, it asks for what is the handspan, or what is the age if he has a handspan of 7. So if I'm looking at this, I'm actually looking at the y value here. So my y value, I'm going to go to 7. And if I go to 7 and I go over, I should see that that correlates with 9. So the answer here is C. So you had to read which value they were looking for in order to figure out whether you were looking at the X or looking at the Y. All right, so number 13, it says a realtor earns a base salary with a commission, and it says select the equation that best fits this relationship. So it didn't tell you whether it was exponential or linear. So that's the first thing we've got to figure out. So in order to figure out whether it's exponential or linear, we need to add a table. We're going to put in our information. All right, so after we put that information in, we need to decide linear exponential. So linear, remember, is y1 squiggle mx1 plus b. Exponential is y1 squiggle a times b raised to x1. Make sure you click log mode. All right, so first thing I'm going to do is I'm going to look at the scatter plot. And I should actually be able to see in this scatter plot that my values look like they're going to grow exponentially. But I can check my actual equations, and I can check my correlation coefficient. And remember, the correlation coefficient is going to tell me which one is a better fit. So I have linear, or I have exponential, and that correlation coefficient is 0.99, so that's a pretty good fit, but we're going to check linear as well. All right, and that one's 0.97, so they're actually both really good fits, but the one that is a better fit is going to be exponential because it has a correlation coefficient of 0.99, and this one had a correlation coefficient of 0.97. So we're going to use exponential here, and if we come back and we go to exponential, it says that my A value for exponential was 1,872.96, and I have 1.00. So if I'm looking at which one would have those values plugged in correctly, the answer for that one would have been A, because we wouldn't have been able to use B and D because those were linear. Okay. And the last one here is another residual problem. It says, what is the residual for the number of apples harvested in 15 years? So remember, to find the residual, that's going to be actual minus predicted. So we know that the actual amount in 15 years was this one. This is the actual value. So we need to find the predicted value is what we're looking for. Well, how are we going to find the predicted value? Well, we're going to find the predicted value by looking at the best fit model. So we're going to look at this problem, and we're going to put in our table because we got to get the equation in order to get the prediction. Okay, that's the whole point of a best fit. All right, I'm going to fit it in there so we can see that that is very much looks linear. So y1 squiggle mx1 plus b. And so I have my equation here is y equals 108.39x plus 240.97. So how do we find the actual predicted value? So for predicted, we're going to take 15 and we're going to plug 15 in for x. So I'm going to come over here and I'm going to do 108.39 times 15 plus 240.97. And my predicted amount is going to be 1,866.82. Now, why did I need to do all that? Because now we're going to take our actual is 8,047. So this is actual. And we're going to subtract our predicted. Okay. And the predicted amount that we got was 1,866.82. So now we can just come subtract that. And I got negative 19.82. So depending on the rounding, we would have gotten negative 19.7, which would have been B. Let me know if you have any more questions or if you need any more help. And you will be going on to the next assignment for Best Fit and finishing up the Best Fit model today with an actual quiz assignment.